Welcome to Crestron Avia. In the previous video, we covered how to create a virtual project, created a new project, and connected a DSP-1281. Now we will explore the navigation and features of the software tool. Welcome to Crestron Avia. In the previous video, we covered how to create a virtual project, created a new project, and connected a DSP-1281. Now we will explore the navigation and features of the software tool. The software will open to a signal page, which should be considered the main page, as most of the other pages relate directly to the signal page. We will explore the rest of these pages in the following videos. Once I am connected to a unit, I can see the full matrix capability of the unit. We will explore the options for adjusting the viewable objects in a little bit. The top center of the window has the information for the currently connected device. To the left of the center, there are two navigation bars. The top allows navigation to various other pages. The home button will take you back to the opening page and allow for creating new files, connecting to other devices, and other things. The control bar below the main bar will change based on which page is selected in the top navigation bar. These secondary selectors provide sub-controls for the page selected. The DSP tool allows me to assign input, output, and auxiliary channel names. They are visible by default. However, you can press the Channel Names button at the top of the window to toggle visibility. Once enabled, each channel displays a text box allowing me to assign it a friendly name. Double-click it to edit the name and press Enter to save those edits. If you are entering all channel names at the same time, type the name and press Tab on the keyboard. It will advance to the next name automatically. Similarly, there is a VU meter button that will show and hide the VU input, output, and aux meters. Directly under the VU meter button is the Custom Views button. Once preset views have been created, they can be easily recalled via the dropdown. The button to the right will create new views. Custom views are utilized for easy-in monitoring and configuring specific groups of objects that have been opened. The custom view will retain which objects are open and their specific location. To access this feature, I will click on the Views button in the navigation bar. You'll notice that the workspace shifts to the right a bit and provides me with a palette for my custom views. I have already created a couple of views for a sample project. Using custom views is very simple. Rather than closing all these open windows and then finding the 6 table mic gain blocks, the aux EQ, and compressor, I can simply click on the custom view labeled Table Mics View. Instantly, all the windows are closed and the relevant mix of controls is recalled. This is a major time saver when commissioning a system. I no longer must search around a large DSP canvas to find the controls I want, and I don't have to spend time laying out custom control screens. With a single click, I have all my desired windows exactly where I left them. To close all of the windows, click the red X above the button to create new views. It will close all my DSP windows. This is my quick snapback to a global view of the workspace. Creating additional views is very easy. First, I will open a number of DSP blocks that I need to keep handy. Once I have laid them out the way I want them, I will create a new view button. I am prompted for a name and I'll call this one mic gates. Then hit return on my keyboard. Now that the view has been added to my palette, if I choose another view, I can easily come right back to my new gates view. Deleting a custom view is done by right-clicking on a disposable view, or selecting it, and clicking the delete button below the navigation bar. The Views page also gives me the ability to create virtual mixers for my matrix cross-point controls. Using the same example of the 6-table mics, I can create a mixer that gives me easy access to the levels feeding into aux2. To start, I will click a new vMixer button at the top of the workspace. I am presented with a blank vMixer window with some instructions. Control plus left-clicking some crosspoints puts them in selection mode, signified by a white border. Once I gather up all the controls I want, I can left-click drag any control in the group over to my vMixer window. Now I see my 6 mic crosspoints as faders, and the respective mute buttons. Since all these mics go to my 2 aux bus, I can bring over my aux2 master as well. I now have a complete mixer for the table mics. Once a vMixer is created, I can save it to a custom view for later recall. Just like any DSP window, and recall is just as simple. vMixers make working with the matrix more visual and easy to control. Note that when I move the fader, the corresponding crosspoint knob is showing the change at the same time. Custom view and vMixers are powerful time savers included in the DSP tool. Learning to leverage them will make you highly efficient in your commissioning exercises. For users with lower screen resolutions, or to maximize screen real estate, there are workspace zoom controls in the top right corner. When working with DSPs that have Dante, the matrix can grow to be quite large. Zooming in and out will allow me to display all the relevant info for a given configuration activity. There are times I might want to stay zoomed in on a certain area of the workspace, but I want to see both input and output meters for a set of channels. I can accomplish this by collapsing portions of the matrix. This can be done by clicking the buttons at the top of the screen that correspond to the sections of the matrix, or by clicking the matrix headers themselves. This is a convenient way to set up my workspace and remove controls that I am not currently working with. Before we dive into the tool, it's worthwhile to discuss some of the architecture of the Avia DSP solution. Traditionally, there have been 2 types of DSPs available: fixed and compiled systems. Fixed architecture systems are great for their simplicity and low latency, but don't allow much flexibility with routing or changing processing objects. Compiled systems, sometimes called open architecture, allows for maximum flexibility but requires far more audio know-how to configure and deploy. This option also has variable latency, which can adversely affect system performance when care is not taken in the development of the processing paths. Crestron's approach with the Avia line is to sit in the middle of these 2 concepts. Rather than requiring the programmer to have extensive knowledge of signal paths and processing theory, we process signals with modular channel strips. To allow for flexibility, you can substitute predefined processing objects to suit your application. This best of both worlds approach allows us to provide diverse processing options while keeping the configuration of the DSP simple, and subsequently keep the latency to a minimum. The notion of channel strips is nothing new to the world of audio systems. This is how live sound and recording consoles work, and how most multi-track recording software is designed. You can use the Crestron Avia DSPs in your projects. You will build up a library of channel strips that can be reused anytime you have a similar application. This allows you to do the bulk of the work once, then apply the DSP channel strip to other similar projects, thereby making similar systems easier to deploy and more repeatable. Crestron provides a complement of output channel strips for our various amplifier and speaker combinations. These strips provide factory presets for crossovers, EQ, and speaker protection. Simply applying the appropriate channel strip to my outputs will get me most of the way to a proper tuned room in seconds. Once the channel strips are in place, the Avia DSPs provide built-in real-time analyzer tools to get me the rest of the way. Now that you are familiar connecting to a DSP on the network and the signal page, let's dive into the configuration of the DSP objects and the matrix operations in the next video. Thank you for watching.